Right, so we know what mole is. We know how to calculate it. We know how to relate it to mass and so on. Now we need to think about how do we do a moles question? Well, basically the standard is to this is the process I tend to teach. I say you look at an equation or you look at a question or whatever it might be, and you're going to be talking. It's going to be you'll have a known substance and you'll have a target substance. So, for example, question one over here, we have aluminium is extracted from aluminium oxide as shown. Calculate the mass of aluminium that can be formed. So we want to know something. We want to know the mass of the aluminium. So that's target substance from 1,020 grams of aluminium oxide. So that is the known substance. So I'll try to use the same color every time. I highlight the known substances in pink and the target substance in green. So what does this? So now we've got that. The second stage is find the molar mass of each substance, target and known. Well, we just look at the periodic table for that, and so we're using the aluminium oxide. We've got 2 lots of aluminium. The atomic mass for aluminium is 27, and then the atomic mass of oxygen is 16. So 27 times 2 plus 16 times 3 gives you 102. Again, the molar mass means the amount of how many grams is in 1 mole. So we can see straight away without even doing any using any formula, that that's clearly going to be 10 moles, right? The known substance is 10 moles. So that's why it's question 1, because it just makes it a bit easier. So we can visualize it and see what's going on. Now, we've already seen the atomic mass of aluminium, it's 27, so the molar mass of aluminium is 27 grams. So the next stage is convert the known substance into moles. We've already done that. We did that with that just from glancing at it. So that's the mass. We know the molar mass is 102, so the moles are going to be the mass divided by the molar mass, which is 10 moles. So now it's this equation here. Looking at this equation, what does it mean? It means that if I had, and I always underline the word if I had 2 moles of aluminium oxide, I could produce 4 moles of aluminium. That's what the equation means. If I had 2 moles, I could produce 4 moles. So the ratio is important here. The ratio of the known to the target substance is 1 to 2. Okay, I know that I don't have 2 moles. I've in fact got 10 moles, but it's 1 to 2. So if I had 2 moles, I'd get 4. So I've got 10. So how many would I get? I'd get 20, because the ratio is 1 to 2. I'd get 20 moles of aluminium. That's the next step. Whoops, I keep moving that thing. To use the equation to find the ratio of the known to target substance, it was 1 to 2, and so therefore, and then we can work out. We can then use that ratio to work out what the moles of the target substance is going to be, which was 20. And the final step is to use that number of moles along with the molar mass to calculate the amount of the actual mass of the target substance. So the mass, which we did earlier on in a previous video, is moles multiplied by molar mass. So 20 multiplied by 27 is 540. So that's how you do a standard question in moles, and there's lots more you can practice down here. We started doing some of them. I think we got the hang of them, and then we moved on to some more difficult ones up here. Okay, so I'll just cut that video there and save it.